Hello and welcome to this video. In this video, we will learn about floating point numbers in Rust. So we have studied integral values. Now we will study floating point numbers. So floating point numbers could be like 5.7. So these are fractional numbers, and I am putting that in variable k. So there are certain constants which are there. Infinity is one of them, nan is another, maximum exponent is another, and if you want, then we can have a min exponent, okay, and we make this L, and then we can print this. So the min exponent and max exponent you will understand in a bit. Don't worry much about it. This is a special number, okay, that's why I put it in there, okay. All right, max exp, min exp. So std colon f32 colon min exp. So it has come here. So we can import it, sort of use it here in xp, min exponent, and then we don't need this qualification here. Okay. So we can run this right inside Visual Studio. So it will compile and run it. So you see our L is 5.7, minimum and maximum exponents are given here. Nan and infinity are there. And similarly, this magic number is there. We will talk about this magic number in a bit. So you can observe that this has a fractional part 0. This is necessary to make a number floating point, otherwise it will become an integer. So you will see there is an error now. Okay, red line. It will tell you that found integer expected f64. So this 0 is there. In Rust, there are two different classes of floating point numbers, f32 and f64. So as the name suggests, f32 will use 32 bits, that is 4 bytes, and f64 will use 64 bits, that is 8 bytes. So if you want to study these in detail, then you should go to IEEE 754 specification of floating point numbers, which will tell you all the details of how floating point numbers work. For our uses, we can focus on this diagram. So sign bit is 1 bit, then there are 8 bits for exponent, and fractionals at 23 bits. And similarly for 64-bit layout, we will have similar thing. We have 54 bits for fraction, 11 bits for exponent, and 1 sign bit. So now let's talk about that special number. Let me invoke Python. And we are going to compute 53. So you see, this number is same as the number here. Now, if you increase this by 1, let's say we make it 993. Let's see what happens. You see, the number did not increase, okay? But then there is another special property of this. If I say 20, then you will see the number will be printed properly, because now these are increasing the exponent of the number. So you can put many zeros here, and you run this, those many zeros will come. But if we make this, say for example 9, and make this 9, we'll see what happens. So it discarded 9 in this case, okay? So because those cannot be expressed at power of 10. So let's say we make this 0. So this you have to be careful about, that this is the maximum integral value you can represent faithfully in floating point numbers. You have to be careful of putting more than this value in f64, because that's as much as floating points can hold, that is 2 to the power 53. So these are exponents. Now we will talk about conversion of fractions to binary. Say for example, there is a fraction 1 by 2. To convert it in binary, you multiply 1 with 2. Okay, so and put a point. So this becomes 2 by 2, which is 1. Okay, so 0.1 is the binary representation. If suppose there is 1 by 3, then point, and then 2 into 1 would be 2, which is less than 3. So we put a 0 and multiply again. So 4 by 3. 4 by 3, so quotient is 1. Now 1 would be remainder, and again 0, 1, 0, 1, 0, 1, 0, 1. So this way we will continue and it will never end. Now there is a mathematical theorem which tells which numbers will terminate from a source number system to a target number system. Consider our source number system has base S and target number system has base T. So suppose this is prime factor S1, S2 up to Sm. Okay, these are prime factors of this base. And suppose the target has T1, T2 up to Tn. These are prime factors of the target number system. Then what mathematics says that this S1 up to Sm should be a subset of T1 up to Tn. Only then a fraction in base S will be terminating in target number system T. Okay, so for example, 1 by 2 has base 2 and binary base is 2. 1 by 2 has base 10 and binary has base 2. So it will properly terminate because the denominator 2 is subset of 2. Similarly, 1 by 4 will have prime factor 2, which will convert or terminate in binary. 1 by 8 will also do that. Okay, so 1 by 2 to the power n will terminate in binary. Any other number, for example, n, this should be n. Any other example, for example, 1 by 3 will not terminate in binary. 1 by 5 will not terminate. 1 by 7 will not terminate in binary. 1 by 6 will not terminate because the prime factor 3, which is one of the prime factors of base denominator 6, is not part of binary number system's prime factor. So it will not terminate. So that is how you convert a fraction into binary. So from this you can understand that all numbers will not terminate to binary. For example, if you want to print 0.3 is equal to 0.1 plus 0.2, so this is an equality test, and it will return false because when 1.1 and 0.2 will be stored, some value will be lost, but when 0.3 will be stored, some other value will be lost when converting. So you see, this should print false. This is equality operator. 0.3 is not equal to 0.1 and plus 0.2. Let's see this in action. So it says false, you see, so it will not convert. And these constants, if you want to refer to, then you can see this in Rust documents. You have bits, precision, max exponent, min exponent, 0, infinity, nan, and smallest. So you can make use of these constants in your code. So I think that covers a lot about floating point numbers, and we have a good base to start introducing some operators on floating point numbers and integers, what operation we can perform on them, and we will see that in the next video. So thanks a lot for watching the video. I hope that I have covered the basics of integers and floating points properly, and if you like this video, then subscribe to the channel and click the like button. You might also want to switch on the notifications by clicking the bell icon. So I'll see you in the next video with more on operations on integers and floating point numbers. Thanks a lot for watching. Happy programming.